The formula, and I'm not going to go through the derivation. There's a nice derivation in the book. It's rather lengthy. So I'm just going to give you the formula for calculating A inverse. And the formula is this. A inverse is equal to 1 over the determinant of A times C transpose. Now you know what the determinant is, but let me explain what this C transpose is. C here is the cofactor matrix. And it is just, if A is an n by n, then C will be n by n also. So it's a square matrix that's equal to this. C11, C12, dot, 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 C1n. That's the first row. The second row is just C21, C22, dot, 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 C2n. And then it goes on, and the very last row is this. CN1, CN2, dot, 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 CNN. Okay. So it's an n by n matrix that corresponds to the original A matrix. See, your original A matrix here is assumed to be this. A11, A12, dot, 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 A1n, A21, A22, dot, 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 A2n. And then you go dot, 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 AN1, AN2, ANN. So you're starting off with this original A matrix that's n by n. This cofactor matrix is just the cofactors of each of these elements. So C11 is just the cofactor of this element. C12 is the cofactor of that element, etc. Okay, so C and A have the same dimension. Now C transpose is just this matrix transposed. So you take the first row in this matrix, make it into the first column in C transpose, etc. Okay. So that's where C transpose comes. Okay. Let's illustrate this with a simple example. I'm going to take the simplest possible example so that this won't be so tedious. And I'm going to make up a simple equation as a very nice solution. Let's just take x1 plus x2 equals 2. And then we have a 2x1 minus x2 equals 1. And I'm making up this equation in the following way. I want the solution values for x1 and x2 both to be 1. So notice we have 1 plus 1 equals 2. We have 2 minus 1 equals 1. So I already know that the solution values are because I made up the problem so that the solution values would be that. So we already know what the solution values are. But let's pretend like we don't know what the solution values are and that we want to solve this equation by the tools of matrix algebra. Then in matrix algebra format, this would be written as AX equals D, where our coefficient matrix capital A is just this. It's the matrix of the coefficients on the variables. So it's 1, 1, first row. Second row is 2, minus 1. Okay. Our x vector is x1, x2. Our d vector of right-hand side constants is just 2, 1. Recall that if we could find A inverse, we could multiply that A inverse times both sides. And then this equation would reduce to this. A inverse AX equals A inverse D. Or A times A inverse, which is I, the identity, IX equals A inverse D. And then we could just delete the identity and then call this X star. X star is just A inverse D. Where X star is a 2 by 1 vector of the solution values that solve this equation. Okay. Now, in order to use this procedure, we have to find A inverse. So let's use that formula we just went over to find A inverse. Recall that A inverse is this. 1 over the determinant of A times the transpose of the cofactor matrix. Let's first get the determinant of A. What is the determinant of A in this case? If you take the determinant of this matrix right here, what is its determinant? Anybody? Yeah, it's minus 1, minus 2 is a negative 3. Notice, had we found the determinant of A to be 0, we could stop. Because then we would know that A inverse does not exist. Okay, but we're okay. Because in this case, the determinant of A was not 0. See, we run into problems. How could you use this formula? What is 1 over 0? It's undefined. So had we found that the determinant of A is 0, we would stop. But it's not 0 in this case, so we can go on. In this case, in fact, we know that A inverse exists. And not only does it exist, it's unique. Okay. The next step is to find the cofactor matrix. The cofactor matrix is defined to be this. So we just have to find these four cofactors. For 2 by 2 matrices, this is very simple. What is C11? Well, following the definition, it's minus 1 to 2. What power? 2. I plus j here is 2. So it's times M11. But minus 1 squared is plus 1. So it's just M11. And what is M11? This is so easy, it might be difficult. What do? You delete the first row and first column. What's left? Just a negative 1. Since it's a 2 by 2, there's only one element, so that is the minor. So the minor here is just negative 1. Do you all see that? So that is C11. It's just a negative 1. How about C12? Okay, now we take this minus 1 to what power? 3. So that's going to be a minus 1, isn't it? So we have a minus 1 times the minor. And what is the minor of this element right here? 2. So it's negative 2. Somebody said that a minute ago. You're right, negative 2. Okay. How about, I'm running out of time, so let me just quickly tell you what the others are. What is C21? What is the cofactor of this element going to be? Delete the second row and the first column. What's left? A 1, but you're going to have to multiply that by minus 1, so it's a minus 1. And what is C22? Anybody? What is C22 going to be? 1. Not negative 1, but 1. The cofactor of this element is just its minor, which is 1. Okay. So that's the cofactor matrix. You transpose it, multiply it by 1 over minus 3, and you got your inverse.